All right, worksheet 8, part 3. So this is the 6th period video. We'll be doing the multiples of 3. 3, 6, 9, ... The test, I mentioned this already, but just to put it on film for the video, 23 multiple choice questions at 3 points each makes 69, if my math is correct. 5 free response questions, and again, they're not free response like free response essay in, A-Push or English or something like that. It's free response, meaning it's not multiple choice. But I showed you examples earlier, reading function values given a graph. It's supposed to be easy, but there are still people who mess that up. So we should be given, that should be not free because it also involves composition and division and all that other stuff, but relatively easy 20 points. That adds up to 89. And so there's one question where you need to put your name on the test. That would be worth 11 points. Yes. But be careful. It's not like I add 11 points to your score. You can't make a 111. It's just if you missed everything, which is unlikely given that there's 23 multiple choice. Anyway, the lowest you could get is an 11. So there are some sort of free points built in, but it's not like an 11-point curve in the normal way you think of an 11-point curve.
Is there a bonus?
There is a bonus.
Is it like a math bonus or like a fun bonus?
What is Mr. Wolf's middle name? No, it would be a math. It will be a math bonus. All right. 3, 6, 9, 12. Do you know Mr. Wolf's middle name? Did we talk about that?
Yeah.
It is Rex. It's a trick question. Number 3. The graph of the function f is given for -3 to 6. Which of the following statements about the rate of change of f? Rate of change of f. What's that mean? Slope. The slope of f over the interval -2 to 6 is true. Okay, so before I look at my answer choices, this thing is decreasing, increasing, decreasing. So the slope is negative, positive, negative. All right, let's see what it says. The rate of change is, from 2 to 6. Narrow down what I need to look at here. So from 2 to 6. All right, the slope, I'm going to replace rate of change with slope because I think that's a little easier to read. That's also what my brain is used to thinking about. So the slope is positive from 2 to 6. No, not true. I mean, it's partially true, but not true. The slope is negative. Well, again, like A, it's partially positive, partially negative, so that's out. So the rate of change is increasing. The slope is increasing. Let's see. So the slope here is like, I don't know, +2. The slope there is definitely 0. The slope over here is -3. I don't know. I'm just trying to get a feel for this. So the slope is, no, it is not increasing. The slope is decreasing. So answer choice D. Why can't the rate of change be positive? Because because it says for 2 to 6. So I got to look over that entire interval from 2 to 6. So the rate of change is positive here, but negative here. So I can't. It would have been more helpful if they'd have said something like always positive or always negative. But you can't say it's positive from 2 to 6 when it's not positive from 2 to 6. It's positive part of the way from 2 to 6. Other questions on number 3? Number 6. The figure shows the graph of a function g. The 0 and extrema for G are labeled. Okay, well, they're not labeled as the 0 and the extrema, but the 0 is A, the extrema would be B and D, like the highest and lowest points. Or E is the overall extrema, the overall max. Let A, B, C, D, E represent the x-coordinates at those points, okay? Of the following, on which interval is G increasing? So I want G to be increasing, and G concave down. Concave down like a frown. So I want G to be, you know what? I noticed it right away. So I'm gonna concave down like a frown would be A to C, because after C it sort of flips over and turn that frown upside down. So there's my concave down, but I also need G to be increasing. So that would be from A to B and from D to E. So where both of those things are true would be from A to B. Kind of easy when you overlap the colors. Number 9. The graph of the polynomial function f is shown. How many points of inflection? That's where concavity changes, where the frown turns upside down or vice versa. Given portion of the graph. Okay, so where does the frown change? So concave down to somewhere in here, and I think this is why it says how many points, because you can't tell exactly where it happens, but somewhere around there it happens. And then it changes from smiling to frowning somewhere around there. Frown, 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 and then it's really hard to tell in here, but somewhere in there it changes from frown to smile. So 3. In calculus, we'll learn how to find exactly where those spots are. But for now, we just want to get kind of the concept down. Yes, sir?
Why can't you count like the number of humps?
Because I almost said it's always one less than the number of humps. I don't know that that's true. 1, 2, 3, 4. There's
the line going up to the why doesn't that line count as starting hump?
this line.
Yeah, but it changes from a straight line to concave.
Well, this is going to be concave down the whole way down. It does not turn into a straight line. Like the further it goes, the straighter it gets, but it never turns into a straight line. So he's frowning all the way until he gets to this spot, and then something brightens his day and he smiles. And then he gets to English class and it's a frown. Then he gets to pre-cal class and it's a smile again. That's how that happened. Something like that. The number of turns, this is kind of related to, you might remember that if it's x to the n, there are n minus 1 turns. Did y'all learn that last year in Algebra 2? And there are n minus 2 inflection points. We never teach that, but so the number of turns and the number of inflection points are related, but we don't ever really teach it that way. And you have to be careful because that's the maximum number of turns and the maximum number of inflection points. Anything else on number 9? Number 12. Oh, the test is entirely no calculator. So I still want to do number 12 because it talks about things I want to talk about. But obviously would not be one quite like number 12 on the test. squared plus 3x minus 5. Which of the following describes f? Yeah, it's talking about the graph. That's why I grabbed the calculator. So let's see what's going on. I don't know about that for a window. See if that gets it. Yeah, good enough. I think I can answer questions based on that. For any interval of x, the function always has a positive, remember, rate of change. It's fancy talk for slope. For any interval that always has a positive rate of change, yes or no? No. I mean, it does have some intervals, but not always. So no. Part B, kind of the same thing. Always has a negative slope. No. I mean, it's decreasing over here, but then it's increasing, so B is out as well. Okay, now we get to some crazy stuff. For any interval less than negative 1.5, okay, so 1.5 must be that the spot where it changes. The function always has a positive rate of change. For less than negative 1.5, we have a positive rate of change. Yes or no? For less than negative, so we're over there.
That'd be no.
That would be a no, because rate of change means slope. We have a negative slope, so I don't even need to read what comes after it. That doesn't work. For any interval less than negative 1.5, so on the left side of the graph, over there somewhere, the function always has a negative slope. Okay, yes, I'll believe that. And for any interval greater than negative 1.5, so over here on the right-hand side, the function always has a positive slope. Yes, which is good because I'm out of choices, so it better be D. So you can easily see how that didn't really have to be a calculator question. We could give you a graph with points labeled and you could go for it from there. Ask the same questions. Number 15. The daily high temperature at a certain point in a river is modeled by the graph. Okay, so that's the high temperature of the river from January to January. Okay, that makes sense. It's hottest in August, coldest in February. Got it. Each point on a vertical grid line indicates the temperature in degrees Celsius on the first day of the indicated month. Okay, so that's a little bit tricky to think about. So that means this block right here, that's January 1st, and then that's January 31st at the end. Of the following, on the first day of which month is the rate of change of the temperature the greatest? So not when's the temperature the greatest, when is, what's our secret algebra word for rate of change? Slope. Now, we can't officially say slope of like a curved line because that kind of doesn't really make sense, but we say slope because it's easier to think about, we're more familiar with it, and it's a little easier to work with. So I want the slope to be the greatest. So February slope, what do we think the February slope is? Well, the first day of February, what's that instantaneous slope? What's the tangent line slope on February 1? I think it's 0. I think it's the tangent line slope is 0 on the first day of February. On May 1, that slope is that. I don't know what that is, so maybe I just better leave that and see if I can visually pick out a better answer. So May's in red. August I'll put in blue. What's the slope on August 1? 0. You know, I can say May is positive. That's about all I can say. And then in November, I think I know my answer. November, the slope is negative. So if the question is which is positive and your choices are 0 positive, 0 negative, I guess we'll go with the positive number. So I didn't have to get into, what are the units and how do I do change in y over change in x. It didn't matter. There's only one that's positive. Kind of threw me off because we did horizontal tangent lines in calculus today. So that's where we're headed. A year from now, that's where we're headed. 18. Oh, another graph. Yes, surely no one in here, there are those people who see that question and they're like, I'm going to circle T and move on, or D and move on. During a month in a certain town, the temperature increases and decreases over the course of a day. Okay, I'll buy that. A graph of the average temperatures during the month for any given day is shown. The data in the graph can be modeled by the function T, where T gives the temperature in degrees Fahrenheit and time after midnight. So that's sort of like the military time down there. 6, 12, 18, 24, time after midnight. At a certain point in the month, there is an adjustment to clocks for daylight savings time. Oh boy. At which point clocks are adjusted 1 hour forward. For example, 6 a.m. instantly became 7 a.m. The function D models the same data as function T after the shift to daylight savings time. If H still represents the number of hours after midnight, which of the following defines D of H in terms of T? Okay, so is this a left-right shift or an up-down shift? Left-right, because it's an hour shift. So which choices can you throw out right away? C and D. Like those are out. So now I got to think careful about which way I'm shifting this thing. So from D to T, 6 became 7. 6 became 7. So that is 6 to 7 is a shift right. Well, to shift right, that would be -1, because the x stuff is backwards. That was a tricky one. No computation at all, just purely conceptual. Shift right means h minus 1. And I think that makes sense if you just tried to plug in some numbers there. So if you're on the T scale and it's 9 a.m., that would be the same as 8 a.m. on the D scale. So yeah, we're good. And that is it for the multiples of 3 for worksheet 8.